students. In this video session, we will see methods of preparation of aldehydes and ketones part 2. First method of preparation for this video is Aldehyde reaction. Students, from this video or in this video, mainly some name reactions we are going to see. In Aldehyde reaction, you can see we are converting alkyl benzene, actually it is methyl benzene or toluene we said, alkyl benzene are converting into corresponding aromatic aldehydes. What is happening? Methyl group attached to benzene ring, methyl group attached to benzene ring is directly converting into CHO group by strong oxidizing agent. Chromyl chloride, this oxidizing agent is chromyl chloride. So again, alkyl group or methyl group attached to aromatic ring is directly converting into corresponding CHO group by action of strong oxidizing agent. Let us see what is happening in this reaction. In this reaction, methyl benzene is reacting with chromyl chloride, is oxidizing agent, chromyl chloride in presence of carbon disulfide or CS2 as the solvent, and we are getting chromium complex. Students, this is chromium complex we are getting as intermediate, and on acid hydrolysis of this chromium complex we are getting corresponding benzaldehyde or aromatic aldehyde. So Aldehyde reaction gives you methyl benzene is converting into corresponding aromatic aldehyde. Name of this aromatic aldehyde is benzaldehyde. Reactant is our toluene. This is your chromyl chloride. This is chromium complex, and final product is benzaldehyde. So Aldehyde reaction, similar reaction we are going to see in next part. After Aldehyde reaction, we have second method of preparation by oxidation of methyl arene by using CrO3. CrO3 is chromium oxide. In this reaction, students, methyl arene reacts with chromium oxide, you can see easily, chromium oxide and acetic anhydride. This is acetic anhydride. We will write for our convenience chromium oxide, acetic anhydride at the temperature of 273 to 278 Kelvin. At the temperature of 273 to 278 Kelvin, and we get the intermediate benzylidene diacetate. This is benzylidene diacetate as the intermediate, and this intermediate on acid hydrolysis we get corresponding aldehyde. This corresponding aldehyde is our benzaldehyde. So in this method of preparation, we have converted into alkyl benzene to corresponding aldehyde by the action of chromium oxide, that is strong oxidizing agent, and acetic anhydride at the temperature 273 to 278 Kelvin on formation of complex benzylidene diacetate, and this complex is on acid hydrolysis we are getting, or we are preparing corresponding aldehyde. Students, third method of preparation of aldehydes and ketones, particularly aldehyde, by side chain chlorination of toluene. Remember students, side chain chlorination. Toluene is benzene ring attached to alkyl group, that is methyl group to it. Means benzene ring will remain same or as it is, and side chain, that is CH3, that CH3 chain will get chlorination, or chlorination of that side chain will take place and we get intermediate for this reaction, and then further step will give us aldehyde. So first toluene chlorination means reaction with chlorine, and you know students, chlorination takes place in presence of sunlight or UV light, therefore this symbol. And sunlight, UV light, benzyl chloride, on chlorination we get benzyl chloride as intermediate, and then acid hydrolysis in presence of heat, that is at 373 Kelvin, we get benzaldehyde. So I will write reaction for the same, then you can understand better way. Toluene on chlorination in presence of UV light, we get benzyl chloride. Benzyl chloride is benzene ring and CHCl2. Two hydrogen atoms will get replaced by chlorine, and this benzyl chloride on acid hydrolysis at 373 Kelvin gives benzaldehyde. So students, in this reaction, as per we have shown, side chain chlorination, side chain of this toluene is getting chlorination, or chlorination is taking place, and on acid hydrolysis we are getting our desired product. Next method of preparation is Gattermann-Koch formylation of arenes. It is name reaction, students, and by this explanation we can easily come to know that it is related to aromatic compounds. What happens in this reaction? Benzene or substituted benzene, plain benzene ring, or substituted, or it means hydrogen is substituted by other groups. Benzene or substituted benzene reacts under high pressure with carbon monoxide and hydrogen chloride. Under high pressure, reagents are carbon monoxide and hydrogen chloride in presence of anhydrous AlCl3, anhydrous aluminium chloride. And what we get? We get benzaldehyde, because Gattermann-Koch formylation, it gives benzaldehyde or corresponding substituted benzaldehyde. Means plain benzene will give you benzaldehyde, but if you use substituted benzene, or means CH3 group or nitro group is attached to benzene, you will get corresponding substituted benzaldehyde as a product. Therefore, Gattermann-Koch reaction gives us aromatic ring, or arene is converted into benzaldehyde or corresponding substituted benzaldehyde. We have next and last method of preparation of aldehydes from esters. We know very well, students, esters are R, C double bond O, O, R. These two R groups, that is alkyl groups, may be same or may be different. Remember, R, C double bond O, O, R means if we have to convert this ester into aldehyde, we will have to reduce it. Means this is nothing but the reduction reaction. preparation of aldehydes from esters is a reduction reaction. Therefore, we will have to use a reducing agent for the same. Which reducing agent is used? Very important name, and please remember this name, students. Diol H is the name of this reducing agent. Okay, Diol H is the name of this reducing agent used for this reaction. What is the name of this reagent or reducing agent? Di-isobutyl aluminium hydride. Di-isobutyl aluminium hydride is the name of this reducing agent. Therefore, ester are reduced by Diol H and then further hydrolyzed in acidic medium to give corresponding aldehydes. This reaction takes place, or this reaction is carried out at the temperature 195 Kelvin, students. And 195 Kelvin, this temperature is maintained to prevent further oxidation of aldehyde produced. Whatever aldehyde is produced, it may get oxidized to again this reactant or for further unwanted products. To prevent this oxidation, this reaction is carried out at the temperature 195 Kelvin.